Hello, everyone. Welcome to IPPM. Yes, please. And as you've noted, we are in Georgia A and not Georgia B. There has been a swap. Uh, if you're here for something else than IPPM, you should probably want to go to Georgia B
Or another.
or another room. So this is an IETF meeting, and at the IETF we operate under the note well. So it is good that you familiarize yourself with it if you have not done so yet. It covers a lot of important things like how we handle IPRs, etc. Um, it is also covering things like how we our code of conduct, how we treat each other respectfully, and so on. So please, if you're not familiar with this, please take a look at it. We are running this meeting over MeetEcho. So if you are in the room, please register yourself with MeetEcho using QR codes or other means. We will be using MeetEcho for all the queuing. We will be sharing slides through MeetEcho. We can run the slides for you, or you can run them, but they will be shared via MeetEcho. We have a link for the notes, but we will need a note taker who can help us actually take the notes. So if anybody would like to volunteer for that, we would be immensely grateful.
It could also be a remote person taking notes. So I do see we have a number of people who are calling in who are not in the room. So if you would like to help us, please let us know and volunteer. We're not going to be able to start until we get a note taker. Anybody? Hello. Welcome to IPPM. We are looking for a note taker. Anybody willing to help us out? You just need to take down notes of any decisions that are made, any conversation that happens. You can do that at the link here. Can we please get a volunteer?
And I mean, if you think it's difficult to do yourself, it's totally fine to be like to have a backup note taker or to be two, especially if you're also presenting. It could be good to have a backup, but we won't be able to start unless we actually have a note taker. So, and like Tommy said, it's just about capturing the most important points. You don't have to reflect the entire word by word discussion. Just capture the most important points and so on, and that would be really useful for us.
Everybody is looking down at their laptops. Somebody. You need to resort to bribery.
Yeah, we might steal some cookies out here, chocolate. Anyone who likes chocolate? Chocolate and cookies. It's a collaborative tool, so yeah.
That's
So
fine.
that's great. Thanks, Giuseppe. If anybody just want to go into the tool and maybe relay some stuff when
Can we get a backup
yeah.
for Giuseppe when he's presenting? Maybe another person who's presenting? Can I call names? Rakesh, do you want to help back up?
Thank you. Thank you. Then we can move on to the agenda. As usual, we will start off with working group documents. We have a number of adopted documents, as you can see. So we'll be running through those first. After that, we will move on to documents that have seen substantial discussion but are not yet adopted by the working group, per usual order. And then finally, if time permits, we have a number of lightning talks. And these lightning talks are going to be pretty much one sliders, very brief, presenting a new work, trying to solicit some feedback. So we will work through these kind of as time permits. But we have a very packed agenda. So unless there's any bashing of this agenda from anyone, which I take as a no, we'll get started with encrypted PDM, I believe.
Do you want us to share your slides? Yes. Okay, great.
Yeah. Okay, next, please. Okay, so there were a bunch of comments that our field for PDM sequence number, this packet and epoch would overflow, and they would not be sufficient to monitor long-lasting connections or things on a very high-speed link. And so we are redoing that. And so what this has to, what the situation really has to do with is the requirements of HPKE. And so we went into the HPKE draft and set, and to see what they recommend for overflow situations. Next, please. And so this is out of RFC 9180, which is the draft for HPK, I mean, the RFC for HPKE. And the relevant part is that you need to have a sequence number which starts at 0. And so they do have, what they really say is if the sequence number overflows, then you have to send a message and you must stop. So that is what we shall do. Next, please. So what we have done is to give us a little bit more room. We've expanded the PSN this packet from 16 bits to 32, and PSN this packet has to match PSN last received. So we had to increase that field as well to 32 bits. Next, please. And so when the PSNTP, that 32-bit counter overflows, we will increment the epoch, and then so then we have another, so we can go ahead and have another set to wait that to overflow. The epoch is 12 bits. When all of that together overflows, then we will indeed send the message as per RFC 9180. That is the message limit reached message, and we will stop PDM. And the thing of PDM, it is for performance and diagnostic metrics. So it is not actually payload data, it is measurement data. So we do not have to restart the session. So you'll just be, I mean, we don't want to lose data, but you're going to lose data. But you got quite a bit. You got the third, you got quite a bit. So, there we are. Any
So
thoughts?
just to clarification question. So when you stop PDM, you let the end-to-end flow, like the data flow continue, you just stop doing the measurements on it.
There's
Okay.
nothing on that.
Yeah.
Yeah, no, it doesn't, it's completely non-disruptive
Mm.
to the end-to-end flow. You just are not going to get data. And I think what we will do is, I mean, get PDM
Yeah,
data.
yeah.
What we will do is we'll probably zero everything out so it's clear
Mm.
that don't look at this stuff. It's not relevant anymore. And I think that we should probably add that in there, because there's an after the fact collector which has to analyze all of this. And so if we just zero everything out, I think that'll be good. Send the message, zero it out, and there we are.
Great. Thank you for doing this. So I got in queue also for a question. So I really like that we'll be clarifying, what happens when you run out. And that aligns with what my assumption was, that we would just stop marking the
Correct.
measurements, and that seems like it's not great, but it's not the end of the world.
Correct.
Um, Now, with regards to expanding from 16 to 32, is is that just so you can go for longer with measurements? And what do we think about the trade-off between uh, getting measurements on these really, really long flows compared to the extra byte overhead of now adding 4 extra bytes to your overall extension
Very
here?
interesting question.
Yeah.
So if you were at the ANRW keynote where they were talking about the hugely expanded speeds and how we're talking about 1 millisecond now across huge pipes and how like the core 400 gigabits are being overflowed by how much how fast everything the radio transmitters are getting to be at the core. I'm really feeling like and now I'll get on my soapbox. A bit is no longer that expensive anymore. I'm not saying just pat it all out, but it's not like the old days. We're not living where on 24 baud anymore. And it's just getting. I think it's just as I say that was a very interesting presentation. I think it was the guy from Microsoft who was talking about that and their internal stuff. Anyway,
Okay,
yeah.
cool. So you don't expect any
Well,
performance degradation or
I
places where you won't be able to use encrypted
PDM.
PDM anymore.
Yeah, so the thing we thought about is that the thing that really is irritating to us in some ways is this proposed draft for 64 bits, 64 bits or bytes.
128 bytes total and 64 for extension headers.
Yeah, for yeah.
But it's bytes, yeah.
64 bytes for extension headers and that's seriously annoying because as I say a bit is not as expensive as it used to be, so we're probably going to fight that. And in our testing across the internet, if it is not somebody at the end point, and I'm talking about a cloud provider, a CDN who's doing weird stuff, this all extension headers work. As I say, you've heard me go on and on about this ad nauseum, I'm sure. But what people are saying is that if you make extension headers too big, we're still okay with those 4 bytes. As I say, I think we're building this as much for tomorrow as today. You know, yeah.
Uh, Potentially not a serious comment, but when I see these things, I was like, oh, we could use like variable length integers like what Quick does, and you could encode it small or encode it really big.
Well, actually, if you go back a slide, if you go back a slide, maybe, yeah. All right. Actually, we actually do that with the deltas and the scaling. That's
Fair enough.
exactly what we do. And in fact, Wednesday morning, we're going to try and see if those people sending stuff up to the Voyager will stick PDM onto there because they're taking days to transmit as it is. What do they care about an extra 60 bytes? 48 bytes. You know what I'm saying? But because that's exactly the situation we wanted to deal with is very, very long. And so we'd rather do it on that rather than PSN. You know what I mean? Yeah.
Got it.
Yeah. Anyway, the got a little more complicated than, a little more carried away than we were thinking.
Okay, so we'll get an update
I will update.
on this soon,
Yeah,
and then
if there's no discussion, I was waiting to update if there's no other, but if people are relatively okay with this, we'll put a new version out. Yeah,
yeah, and
cool.
I guess Warren's not in the room. I know he had those
I know,
comments,
I know,
but
I know, I know.
yeah,
Yeah, so
we'll
we'll
track them
deal.
down. Thank
That's
you.
right. Perfect. We'll talk to him.
Okay.
Yep. Thank you.
Thank you. All right. Next, data integrity. Favorite topics. How do we make these things secure, man?
Hey everyone. So this is the usual update on integrity of IOM. Next slide, please. And we got good news actually because this version, at least for us, we think it addresses, Ben's review from the SecDR, early SecDR review. We also took into account the feedback we received in Brisbane from the working group. So thanks again for that. And so we think I said it's ready for working group last call in the slide, but it's almost ready because we got 3 questions again for the working group just before that. Next slide, please. So the first one is just a yes or no, or don't care. It's also a valid option. To provide some context, the NIST provides some recommendations on how you construct the nouns and also on its size. And so basically we use the same recommendation, but we used a recommended initially, and then we decided to replace it with a must. So obviously the advantage of a recommended is that it's not that too restrictive. So you have some liberty as an operator or as a vendor to implement it the way you want. But the must provides 2 big advantages. The first one is security, because if you follow the specs, the NIST recommends to have a nonce of size 12 bytes and to construct it in a specific way. If you use it that way, you optimize the key usage, so you don't have to play with key rotations and stuff, at least not that much. And so that's really something we want. And the other point is from interoperability point of view, it allows us to store the ID of the encapsulating node inside the nonce so that the key can be retrieved easily by the validator. And it also provides some facilities to protect against replay attacks. So just a simple question, do you think that using must instead of recommended here is okay? Maybe should we have a poll? Maybe, I don't know. Or you want to do that at the end?
I mean, okay, Greg, please comment. I think getting comments or just like thumbs up, thumbs down from people is good here before we do actual number polls.
Yeah, we're gonna have 3.
Exactly.
Greg Mirsky Erickson. So if I understand correctly, so the must means that their security nonce must be always present, regardless whether the domain deemed trusted or not.
Only if you use the integrity protection option.
Oh, okay. So
if you don't need it, then you just use the usual
okay,
option
so
types.
okay, so then
Sure.
the use is optional, but if it's used, then that's a must.
Yeah.
I think that's reasonable.
Yeah. Yes.
Okay. Thank you for clarification.
Yeah. So just based on your comment, if you use this, extra header, it's a specific option type. So for instance, you get the pre-allocated trace option type, you would have the integrity protected trace option type, which is another code point actually.
Does anyone have any objections to making it a must? I think that sounds quite reasonable.
Yeah.
I love these like normative, like must, if you do these things, then you must do this. It's like, okay,
Exactly.
Great.
All right, next slide, please. So this one is more to choose between option A or B. So in the integrity protection header, you got a field that is called method ID. So basically, it defines what method, what algorithm must be used by a node to compute the ICV. And so the draft says the following right now: if a node encounters an unknown value, it must not change the contents of the IOM integrity protection header and must not change the contents of the IOM data fields. In other words, the node must not process the IOM option type. So this is what is currently present in current version, which means that if a node receives a method ID that it doesn't know, it does not implement, it would not add its IOM data anymore. So it's kind of having IOM not working for that node anymore, right? So as an alternative, we have the same text and we just remove the last part. And we would have, if a node encounters an unknown value, it must not change the contents of the IOM integrity protection header. So in that case, you would insert IOM data no matter what, but at the end, it would break the validation of the integrity protection, right? So we cannot have an agreement between what first. I'm personally more for option A, so the first one on top. Frank, for instance, is more for the second one. But I'm afraid that if you go for the second one, so the one at the bottom, we would, again, from an interoperability point of view, we would break, the whole thing. And since it's new code points, it's like new options. So if you want to use the integrity, just use integrity. If it's not okay, just use the other one. So again, I don't want to influence opinions here, but yeah, just so that you have the reasoning behind that. So
Greg Mirsky, Ericsson. So what would be expected behavior of decapsulating node if it understands their value of the method ID?
well, actually in the draft, we provide some mitigation from performance risk point of view. So the validator is not necessarily the decapsulating node. So the decapsulating node can just delegate the work. But anyway, let's just assume that the decapsulating node does the validation. If it doesn't know the method ID, then it's not possible to validate the ICV. So the IAM data fields are considered not checked.
Yeah, but if the decapsulating node understands the method ID, uh, although there were some transit nodes that did not.
Yeah, that's more from transit nodes point of view that we are thinking about it here. Yeah. So if you got a trace, let's say we got A, B, C, D, and B, C being transit nodes, A and B, NCAP and DCAP. Let's say that B and C do not understand this method ID, you would have an empty trace. Well, B and C wouldn't insert data fields inside the trace, right? So
right, that's something that I was thinking towards, that because the missing data might be a good clue saying, okay, there was something that was not interpreted properly.
yeah.
So, but if an implementation, because if I understand correctly, their second option of the text allows for the transit node to add.
In that case, B and C would insert IOM data, but then they wouldn't have to update the ICV. So at the end, the validation would fail no matter what.
So that's then what's their benefit of adding this data? If the data, because that's what I'm asking from the point of view of decapsulating node, a node that analyzes their record, the operational state information. So if this information will be discarded anyhow, so then might be the first option because it's more deterministic and more strict.
I agree.
So seems like it's reasonable text.
I mean, I understand why Frank would prefer option 2, because you want to have IOM data fields no matter what. But again, if it breaks the IOM protection, that just use the normal option type without integrity protection in that case. And so I agree with your comments. Yeah.
Yeah. Okay. Thank you.
Yeah, I just got in queue to also. So I think the first option, I think it's just more consistent.
Yeah, it feels like that. Yeah. Otherwise, you kind of have half working and the other half not working. All right. Next slide. Yeah. So this one is a little bit more complicated because we don't have a solution right now for this. So whatever the option type, a transit node must not participate in the integrity protection, which means it does not have to update the ICV if it does not add or update IOM data fields, right? So if it does kind of nothing, it makes no sense to update the ICV, right? Otherwise, you break, again, the integrity protection mechanism. So this is mandatory here. And so we had this text in previous version that we removed until we got a working solution. So it was if the transit node does not add any IOM data fields, for instance, it only modifies mutable IOM data fields or does nothing, then the transit node must not update the ICV field in the IOM integrity projection header. So we thought that this one was working and quite cool, but in the end of the day, it would not work for pre-allocated trace. Because if you think about it, in pre-allocated trace, the NCAP node would pre-allocate the space for the IOM data fields. So it's like they are already there, maybe not initialized, but the transit node would not really add data fields, right? It would kind of update or modify the block that is pre-allocated, right? So I think it's confusing, and we probably need to find another wording for that, because here it's like those data fields are considered as mutable and not immutable. So the question is how to distinguish the pre-alloc case from the others, and we're still trying to find some text to represent that. So if you have any suggestion, again, right now or on the mailing list or offline, we are yours. It would be really appreciated. Because it's really a matter of several words, but it can change the whole context. So, and we really needed that because otherwise you get some transit node that would screw that thing up. So,
Do we have any immediate comments to that? Then I would suggest the group to read this carefully and think about this carefully and provide some suggestions and discussions on this.
Yeah, I would expect, comments later. And oh, by the way, I got a talk on IOM integrity in the next slot in ANRW. So if you are interested, just come by.
Great.
Okay, I'm done.
Anything else? Good. Thank you.
Thank you.
Got time back.
Hybrid two-step.
Okay, so this is update on new version that addresses the comments received during the working group adoption poll. And I appreciate the comments from Bjorn and Martin. Next slide. So what is a hybrid two-step? The hybrid two-step, it's a method of collecting operational state and performance parametrics from their hybrid measurement methods, for example, IOM or alternate marking method. So the idea is that, for example, the method, the direct expert of in situ OEM allows for local policy to control how this information being collected. It could be that each of their information elements being exported as a raw data for the collector and for further network analytics processing. Or in this method, what basically we create a sequence of packets that follow the same path as the original trigger packet, and thus simplifies the correlation of these informational elements so that they can be further dispatched for the processing to the collector or by the decapsulating node. So the method works for point-to-point and point-to-multipoint environments, eliminating the duplication of their information, because one of the things that, as we discussed, original for, and that's been addressed already for in situ OEM, but when it was only oriented for pre-allocated or incremental method, then there was a observed their behavior that in point to multipoint multicast environment, this information that been collected already upstream will be replicated in all downstream branches of their multicast distribution tree. So that's something that obviously we want to be able to eliminate and avoid. So now extensions to in situ OEM allow to do that, and so that hybrid two-step protocol. So next slide. So what we received very good comments during the adoption from Martin and Bjorn and addressed them, and they checked their resolution and they agree with that, approve. So let's go next. So the operational considerations, so created a new section and explaining so how their hybrid two-step can be used by in situ OEM. Uh, their next would be looking into how it can be used by alternate marking method. But basically, so what we explain is um, how many outstanding trigger packets could be floating in a network, given that, for example, for IAM direct export, there are two optional parameters. One of them a flow identifier and a sequence number. But in fact, they're hybrid two-step by collecting traversing the same path as the trigger packet and collecting all these informational elements from the transit nodes in a single packet eases the requirement for correlation of the data with the trigger packet. So thus, flow ID and sequence number doesn't have to be used. Next slide, please. So next step is that, as I mentioned, that we'll look into the applicability of this method with the alternate marking method, and welcome your comments, questions, and suggestions. So, and another question is, so do you think that applicability of to the specific data plane in IPv6 and MPLS to be done as a part of this document, as a part of another a new IPPM document, or probably it's go to the respective working group like 6man and MPLS. But so something that appreciate your opinion on the mailing list. Okay, thank you. So I guess.
Any comments, questions? We have a sleepy room today. Sorry about
No,
that.
just thinking.
I,
I
they're
caught
all
them.
they're
I caught them off guard, so they're thinking.
yeah they're pondering your words.
Intensely. Okay, so so we can go to the next presentation. I'll save you more time. It's always good to have extra time. Okay, so again, appreciate their comments and feedback discussion that we had during the working group adoption poll. And although there were not extensive comments, but I believe that comments from Tal in discussing of security considerations were very important. As always, the security consideration is important topic, and it's better to be proactive in addressing. So that I wanted to reflect this discussion that we had with Tal, and there was some minor update that applied resulting from this, from addressing Tal's comments. Next slide. Okay, so thank you for adopting this work and security-related discussion. Next. So Tal raised some questions. One of them is monitoring mapping of DSCP and ECN. And we believe that it's already can be achieved not using, not extending functionality of this new uh, rate measurement and multicast. So basically what we call the asymmetric uh, stamp extension, but using existing class of service TLV. So the class of service TLV, as it was standardized in 8972, allows not only to monitor change of DSCP and ECN at the session reflector, but at the same time to have a testing of DSCP marking and remarking on upstream and downstream one way. So because their session sender can specify the value of DSCP marking that must be used by the session reflector. So another is that was the question, so why would we need this, why not to rely on um, stamp Yang model? And one of the reasons is that it's beneficial to have a control from the session sender if the session reflector is in a stateless mode. Okay, next slide. So then some security issues. So some security issues were that what can be done to secure and mitigate the risk of amplification attack, because as you recall, so that this TLV allows for number of reflected packets being transmitted by session reflector in response to a single test packet received. So again, here we recommend using HMAC TLV or authenticated mode. So that actually that gives you flexibility because their base stamp test message can be clear, and only extensions will be authenticated using HMAC TLV. But authenticated mode obviously does their authentication of the whole packet. So one of the question is that do we want to set an, limits on the range of how many packets can be requested to reflection from the session sender? And the view that in philosophy, so to speak, we have is that it would be a function because again, so requesting too many packets being reflected or too short an interval puts an load on a session reflector. And it will be up to session reflector either follow this request or respond that saying, no, that's too much, I cannot handle it. So rather than limit their number of packets and range in the request that being transmitted by session sender, so it's an option for the session reflector whether go ahead and following this request or say no with one single packet and using the unknown flag in the flags field saying no, I'm not following it. Its request is too ambitious.
You want to take a question now?
Yeah.
So Ignacio, please.
Hi. Thank you, Greg, for the presentation. Just a simple question. You say that it's two-way measurement. I mean, it's round trip time, isn't it? Or are you trying to, because I'm a little confused about if two-way or one-way. The idea is measure the time, the round trip time with the reflector or one other.
Well, as okay. A stamp is an evolution of T1 measurement protocol. So you will recall that it's capable of measuring one-way delay and packet loss.
Okay, because
The reference here to round trip time is that as an estimate for frequency of trigger packets in certain environments. And we discussed that there was a question from Bjorn, if I remember correctly. So what we agreed is that because to have this consistency, we wanted to have round trip time. But as a protocol, STAMP is fully capable of measuring one-way delay and one-way packet loss.
no, but yes, but to do that, you need some synchronization among nodes.
Yes, that's again. Synchronization is beneficial, of course, but there are techniques of calibrating offset in clock so that that can be accounted for when calculating metrics. Okay, so if we go back to OWAMP and TWAMP, so the clock synchronization there is not requirement. It's definitely a strong recommendation, but before proceeding with the test session, the clock calibration is will be
Okay,
required.
just a simple question, because if you are sending a packet in one timestamp here and you receive here, if the two clocks are not correctly synchronized, you cannot determine the time between the two ones. Okay, this is the point. But okay, I don't want to take more time, but eventually I have a proposition to make synchronization of the clocks in the very simple way. Perhaps I will submit later into the group.
Okay, that will be great. I really looking forward for discussing how to address this because yes, I agree. Accurate clock synchronization is paramount, or at least
Okay.
understanding their clock shift and
Okay.
stability of the clock as well.
Thank you, Red.
Thank you. And yeah, so again, so there was some questions that Tal raised in regard to the human error, misconfiguration, and mitigating excessive packet reflection. So we believe that most of it can be used by using HMAC extension for authenticating stamp extensions in this particular extension, if that's the case. Next slide, please. So it looks like we got a good response for our proposed updates, and we look for more comments and would like to invite them. And hopefully by next meeting, we'll be ready for the last call.
Tom?
Okay.
Yeah, can you hear me? Can you see me? Can you see me? Can you hear me?
Yep, we can.
Yeah, great. So Greg, thanks for addressing my comments. Just one question, which I'm not sure about. You mentioned using the HMAC TLV in order to be able to mitigate some of the amplification attacks. Just one point that would be worth checking, I'm not sure about that, is whether the HMAC TLV can avoid replay attacks. Because basically there's a possible threat where an attacker can record a test packet with an HMAC TLV and then replay that in order to recreate that amplification attack.
Oh, you mean the replay? Yes, but at the same time, right. So this asymmetrical extension, because it requests multiple reflection, possibly multiple reflection packet being transmitted in a succession of maybe a short interval of time. So yes, that might be that it will pose some risk, um, although it's basically it's the same risk as any other case of using HMAC. But let me think about it, how it can be further protected from the replay attack.
Right.
Because
Thank you.
if I understand your question correctly, that basically there, if legitimate packet with the HMAC
Right.
can be replayed, that might be used as a attack vector.
Right. Exactly. Yes.
Okay, yeah, I think that there are some ways to mitigate that risk, but I need some time to think about it and just put it on the paper.
Okay. Sure. Yeah. Thanks.
Rakesh, yeah.
Rakesh Gandhi from Cisco Systems. So regarding that security, and I haven't looked at the latest draft updates, but there are two points. One point was that reflector can always have a validation check to make sure that the packet comes from the right source. So it's locally provisioned value. You verify it and say, yeah, it's not the security issue. So this is something we had to do it for segment routing when we did that RFC 9503. We added some text for it for the source. And the second thing in the consideration, the sender itself also has a rate limiting for the replies that comes to it. So if there is something, maybe reflector is misbehaving and sending a lot of packets back, the sender itself can also do a rate limiting to not get overwhelmed. So those two considerations could be helpful.
Yeah, that's very helpful. But I was already in the back of mind thinking of Tao's question. So one of the probably well-known and broadly used replay attack mitigating tools is the monotonically increasing sequence number. So basically, that very easy to use to detect whether it's a replay or as a matter of fact, because the packet itself, not extension, but packet itself has a sequence number to do packet loss measurement and detect reordering and replication. So basically, we already have a sequence number. It doesn't have to be replicated into the TOV itself. So probably just, text that's pointing, oh, by the way, that can be used to mitigate replay attack because you have a sequence number in a base stamp packet. So probably would be very easy. But thank you for your suggestion. It's useful too.
And since you mentioned sequence number, and there was a question on the one-way delay and one-way loss, um, agree that in order to do T2 minus T1, they both need to be using the same clock in order to do the math. But for the one-way loss, since we say that applicability, stateless reflector, and things like that, um, if you want to do one-way loss, then you need a stateful reflector because it has a state for the forward direction sequence number and reverse direction sequence number and stuff like that. So it's just a consideration that just to the previous question about one-way loss kind of thing, that this has some intersection with stateful and stateless.
Yeah, but thank you. But I think that their point was, and it's a very accurate and correct, appropriate point, is that for one-way measurement comparing to when we're doing the round trip and then we estimate one way by dividing in half, which is an only estimate. So to get accurate one-way measurement, clock synchronization with a particular accuracy is very important.
Agree. Thanks.
Yeah. All right.
Okay.
Good
Thank
discussion.
you.
Thank you.
And always, again, comments are welcome and much appreciated. Thank you.
All right. Now you two swap.
Yeah, good afternoon, everyone. My name is Rakesh Gandhi, and presenting the stamp extension for reflecting stamp packet extension headers draft on behalf of the co-authors. Many thanks to the working group for adopting and supporting and reviewing the draft and providing lots of good comments. I think we have addressed a lot of comments, and there are some good comments as well that we'd like to socialize. So hopefully it doesn't take 15 minutes, but let's see how it goes. Next slide, please. So agenda is to go over the requirements and goals and scope of the draft, the summary of the procedures to provide the context, various review comments. Uh, there is some work going on for extents in other working groups, so just flash the slide on that and the next steps. Next slide, please. So the requirements is that to reflect the extension headers for stamp. It could be IPv6 extension header or the MPLS network action substack M&A work that's going on. The objective is two-way as well as one-way measurements for hop-by-hop measurement as well as H2S measurements. So that's really driving the work. The goal is that we want to leverage the existing implementation of those extension headers on midpoints. Recall that midpoints do not process stamp. They are agnostic to it. And also try to avoid the IPv6 and MPLS protocol extensions as well as part of this work. The scope, it is stamp, then stamp TLVs, the IPv6 extension headers, as well as the M&A substack. It's the draft is going through working group last call in MPLS now. So hopefully it will be RFC soon. Next slide, please. So just to summarize, on the sender side, the IPv6 extension headers are added. And in order to receive those packets back as stamp TLV, the empty TLVs are added in the stamp packet. And on the reflector side, basically, it copies the extension headers into the stamp TLV. And by default, it will also maybe put the same extension headers in the reverse direction. And we call it two-way measurement because now you see things are symmetric in both directions, just like stamp test packets. Next slide. Idea is the same for MPLS data plane. In this case is the M&A substack, which kind of mimics the IPv6 extension header and works the same way for two-way measurement by default. Next slide. So there is one ambiguity. There was a highlighted, and the ambiguity is that there may be some cases where there are multiple extension headers with the same land, and maybe we don't want to reflect one of them with the same land. So it's kind of ambiguity. And the solution is that we can add pre-field some fields like option type or length. This way reflector can match on them and reflect what is requested. And same way for IPv6 or MPLS. MPLS has the same kind of opcode and TC and TTL fields that we can add as well. So if it's zero means don't check. If it's non-zero means check and reflect only that one. So this was one solution proposed for that ambiguity. If it's, so the one in the red color in this presentation are not in the draft. Just wanted to socialize some of those points before we update the draft. So if you have any suggestions, please let us know. Next slide, please. So this is, it was a great comment to add the use the reflected control TLV to not send the extension headers in the reverse direction. So it's kind of one-way measurement, and basically if there's IOM, no recording happens in the reverse direction. Just wanted to highlight that when we add this extension header control sub TLV, means either you are adding all of the extension headers in the reverse direction or none. So there is no control say add this or don't add that. It doesn't work like that in the draft right now, and we'll clarify that. And obviously, we don't want to insert the receive routing headers back into the IPv6 because routing and SRH would have been for the forward path. So we'll clarify a couple of points along those lines. Next slide, please. So this one just shows an example, packet flow basically, where we see that IPv6 extension headers added on the sender side, but not on the reflector side because there is a reflected test packet control TLV present in the stamp. But then we still copy the whatever received in the extension header into stamp. Next slide. And the same idea for the MPLS case. Next slide. So we have some examples of IPv6 extension headers that carried in stamp. There is some description. This was the motivation for using IOM, various option types for the hop by hop and end-to-end measurements. But there were also comments about how about IPv6 segment routing, the header reflecting that. There are a few other extension headers as well. I know GCP talked about alternate marking. So we'll discuss or socialize them and update the draft accordingly. Next slide, please. So this has been there in the draft from the beginning. Idea is to, if you want going to do hop by hop measurement, to use let's say pre-allocated trace option or POT option or direct DAX option if you want to do hop by hop telemetry. Um, and basically stamp carries this just like a data packet, and this is just used for the active measurement along with IOM. Next slide, please. So this is comment that was from Tal as well as Xiaomin in the beginning. Um, so we reflect today, and I think Greg touched upon this earlier. We have class of service TLV. We reflect the traffic class and whatnot. We also have source address, destination address ports. Um, there is also TTL. But what we don't have today is the flow label. We don't have next header fields, for example. And there are use cases as flow label is used for ACMP. Maybe we want to reflect it back. So there is one gap. We could maybe put the flow label in the reply packet the same value as what we receive. And this way we address that as a default behavior. Uh, but then there is another comment about what about SRH? So SRH would be part of an outer IPv6 encapsulation, and it may have different fields than the inner IPv6. For example, it may have a different DSCP, it may have different flow label and whatnot. So maybe we can also reflect the outer IPv6 SRH headers. This way, if stamp packet gets encapsulated along the way, it can be sent back to the sender saying it received this treatment because it had this kind of encapsulation. So this is not in the draft. There were some comments, and let us know what you think. Next slide, please. Uh, there were comments from GCP. Probably we should discuss a bit more. I think idea was that we can also use the stamp for alternate marking for IPFix YANG push along the way. And there are consideration in a different draft along those lines. So right now, there is no use case example in this draft that talks about that, and also doesn't have a case where there is no extension header to be reflected and no insertion of the extension header in a reply packet, for example. So this is not there, and it's also something to discuss. Next slide, please.
Would you like to take the comment from Giuseppe now, or
Sure, yeah.
in the end?
Yeah.
Just I want to highlight that regarding this comment, I propose a new draft and is in the Lightlink talk that aims to apply both IOM and alternate marking for any active tool, so including STEM. So I think that it's better to have a separate document for that. Maybe we can further discuss also later, and we can cooperate on that document if you are interested.
Yeah, let's
But-
talk. Let's talk after the meeting then.
Yeah, yeah.
Okay. Sounds good. Thanks. There was a comment from Zhenxiang about having specific use cases because there is a lot of extension headers and stuff, but what does it mean? So the use case would be using the existing, using basically leveraging the timestamp and sequence number from stamp and how you would do it for direct export or for Hobdila measurement and things like that. Maybe we can add few examples in the appendix just so that the extensions are appreciated in the, by how it solves some problems. The next slide, please. So it requests the few code points from your INA, a couple of stamp TLV types, and sub TLV for the asymmetric packet, the header extension header control that Greg's draft. Next slide. I think this might be the. So just to highlight, or there is some work going on in other working group. There is a draft in spring. It talks about two-way measurement mode, one-way measurement mode, loopback measurement mode, and loopback measurement mode with timestamp and forward. And using, let's say, in two-way, we were just discussing that there's 4 timestamps. In one way, there are 2 timestamps to do T2 minus T1. We have loopback as well as some segment routing network programming functions there as well. So welcome your comments on that. Next slide. There is some extension in MPLS working group to use stamp with generic association channel as well. So let us know what you think. Next slide. So we'll update the draft with the review comments. We'll socialize all the things we had on mind. So please let us know. And before next ITF, we'll update it. Welcome your comments and suggestions. And if things are good at next ITF, then we can start talking about last call. That's it.
Sounds good. Do we have any more questions or comments on this document right now? Seems not. Thanks a lot. So please engage and discuss these updates until the next meeting.
All right, and next up, Bjorn.
Yes, hello everyone.
Hello.
I wish I could be there in the room with you, but this will have to do. All right. Yeah, next slide, please. Okay, so the plan for this talk, haven't really been any updates to the draft since the last meeting, but we have some ongoing work on validating the quality of outcome metric with various applications and testing sort of where the thresholds are. So this talk will cover a few specific applications that we've done the testing with and try to answer this question. So what are the latency thresholds for perfection and uselessness for these apps? Next slide, please. So first, perhaps a quick refresh on the quality of outcome metric and score. So the goal with this is to produce a simple metric that is useful for operators, application developers, and end users. And we've based the framework on the quality attenuation work from the Broman Forum, TR452.1 there. And what this standard does is to specify how to measure latency distributions and include loss as infinite latency in those distributions to produce a composable network quality metric that has a few very useful mathematical properties. And what this draft suggests is to basically make measurements using this Broadband Forum tool or framework, I should say, and then to apply some thresholds to some per application or per application type thresholds to then be able to translate the network measurements into per application quality scores. And this is visualized on the right side of the slide here. So the blue line is a CDF of the measured network latency. And then these horizontal lines represent the quality thresholds that are used to produce the quality outcome score. So on the left side, you will see like dots labeled 100. And these are horizontal because they are associated with a specific percentile. So what this line is saying is, or what the bottom line is saying is, if the latency is better than the dot labeled 100, then at the 50th percentile, then the network is good enough or better than what the application needs to perform as well as it can. And then if it's to the right or of the 0 point labeled point, then the network is basically so bad that the application can't function well or worse. So we have these thresholds for different percentiles of the distribution, and then if the measured line crosses one of these thresholds, we basically do a linear interpolation between them to produce a quality score. And if it crosses more than one line, then we take the worst one. So we always take the lowest score of these different lines. So that's what the draft specifies, is basically how to do this. Next slide, please. Okay, so the work that we've been doing involves a simple test bed, which has a device running an application, and then it has this purple or pinkish box in the middle, which is a network impairment emulator. We run we run latency measurements alongside the application, and then we collect whatever in-application telemetry we can to get things like video resolution where that is applicable, or frame rates, or other quality metrics that the application measures sort of in the application layer. Then we export all of this to the database and do some data analysis on it. So next slide, please. So this is what the results look like for a specific live streaming application, and the one we've used is Twitch in this case. So this chart probably merits some explanation. So on the x-axis, we have the frequency of adding latency. And that is no, that is actually not the best way to put it. It's how many packets. Sorry. Every it's so this for the vertical line labeled 20 represents the measurements where 1 out of every 20 packets have added latency. Then it's like 1 out of every 40th packet, 1 out of every 60th, and so on. So the rightmost measurement here represents the case where 1% or 1 out of every 100 packets have added latency. And then the y-axis represents how much latency is added to that fraction of packets. and the latency is added to the packets at random. So in this, for this rightmost red point, we have 1.5 seconds of added latency to every 100 packets. And what these lines represent, so the red is the threshold where the app degrades from perfect to not perfect. And for Twitch, that is looking at two things. It is either so the application is not perfect when it's either the resolution drops or there are or frames are dropped. So there are two things can happen if you have a live stream. Either the resolution is not perfect or as good as it can be, or frames start to drop. And then the blue line is where the app stops working, which means the stream cuts out at various points and starts to buffer. And so what we can see is if we add a relatively small amount of latency, but we add it very often, then that breaks it very quickly. And as the latency is added less frequently, or sort of the added latency events become more rare, then the amount of latency that you have to add has to go up for the app to actually start degrading noticeably. Okay, next slide, please. So this is the same kind of plot, but for Call of Duty run on a PlayStation 4. And this plot is set up in the exact same way. The main thing to notice, I would say, is that the latencies are now much lower. So the y-axis goes, it maxes out at 500 milliseconds in this case. And for the red line, if you add just 128 milliseconds in this case to 1 out of every 100 packets, then the player playing the game starts to notice that it's the game lags even if it's just walking around in the game. Okay, next slide, please. So this is the video conferencing case where we've tested with Google Meet, and here we see a similar trend to the gaming stuff where the distance between these two graphs is quite high. So the app will keep working even if you add a lot of latency, but the threshold for going from sort of perfect to not perfect is very low. In this case, 230 milliseconds for 1% of packets. Okay, final slide, please. And next slide, please. Yeah, okay, thanks. So this is still early work, I would say, but we can draw some preliminary conclusions. So first, that the data supports this statement where we can claim that interactive applications are impacted by relatively rare latency events, 1 out of every 100 packets, even when the added latency is relatively small. And then also there might be some neat scaling laws here, where if you run a few experiments for a specific application, you might be able to extrapolate and so that you don't have to do as much testing because that it might be an expensive and time-consuming thing to do. So that's what I have to present today. Thank you for your attention, and I'll take questions if you have time for that.
Thank you. Ignacio?
Thank you, Georg, for your presentation. Very interesting. I have a couple of questions. The first one is how you test the quality of the application. Okay, you just introduce some delay for 100 or 20 packets and so on. This is what you do. But the second one is I didn't get how you because in the blue line you can put the figure that you want when you have the blue line and red one. Why, even if you take one packet over 20 or one packet over 100, you have not a stop working situation. I couldn't understand why the application is not working. For example, in this case, Google Meet, you say, okay, I got one packet over 100, I added, I don't know, 300 or 200 milliseconds, and that stopped working.
I'm not sure I understood the question.
The blue line, you say, is not working, the application is not working, okay? But it's, for me, it's very strange that you got one packet over 100, you add 200 milliseconds, and the Google Meet, it doesn't work.
Yeah, what this plot shows is if you add 3 seconds to every 100 packets, then it starts to have problems.
But it say milliseconds in your graph.
Yes, 3,000.
Yes, but it's very small gap, and you say that it doesn't work. I mean, how do you test that it doesn't work? You have you have some people regarding the communication. How do you measure the quality in this case? You have, I
Yes,
don't know.
we have someone running the application and observing what happens. And in practice, what happened with Google Meet is that the call would, for the blue line, it would drop. So it would disconnect. But I'm happy to provide some more detail on exactly what the test setup does. If you post a question on the mailing list, and I can add more color to this.
All right, and Ignacio, I muted you to prevent the feedback. But yeah, thank you.
Thank you for the question.
All right, Warren.
Wow, I'm not that tall. Quick question, and apologies if I missed it. So when you're adding some latency, sort of 1 in every 10 packets, is that you do 9 packets and you add it to the 10th one, and then another 9 and you add it to the one after that, or is these like statistically distributed?
It's statistically distributed, so it's a dice roll for every packet, and that might actually explain, or that might actually answer your question as well, Ignacio, because the reason these left side, the blue line is very low on the left side. Like if you add 150 milliseconds every 5th packet, that doesn't sound like too much. But the reason is that we're adding that delay, and then that blocks the next packet. So if you basically if you add enough here to create a queue that never empties, then that breaks the application. Whereas up here, it might break for a different reason. In this, like on the left side of the plot, it breaks because it doesn't get enough bandwidth. On the right side, it might break for different reasons.
All right, thank you. It sounds like we have some more good things to discuss on list, and thank you for sharing some of the actual data points here. I think it's helpful to ground this in concrete things. So much appreciated.
Thanks.
All right, just all right, and yeah, we need some backup note taking for now. So thanks, Rakesh.
Yeah, hello everyone. This is the update about the alternate marking deployment draft. So I'm presenting on behalf of the co-authors. Next slide. Yeah, just a recap about the motivation. So this draft aims to provide more guidance about the alternate marking deployment. So you know that the alternate marking is already published as RFC 9341 and 9342. And the scope of this draft is focused on the manageability aspect. So you see in this picture that the draft aims to provide guidance about the application on limited domain, the configuration in terms of YANG model, PSEP, BGP, and data export in terms of IPFix and YANG push. All these aspects are not covered in this draft, but this draft want to be a reference for who is willing to, let's say, deploy alternate marking graph, alternate marking method. So it can refer this document and find all the pointers to the relevant extensions and application of the methodologies. So the scope is to clarify several aspects. So the deployment domain, the type of measurement, the configuration aspect, the export, as I said, the encapsulations available, the implementation, and the security guidelines. Next. Yeah, just a few words about the deployment domain. As I mentioned different times, the alternate marking has also other on-path telemetry will be deployed in a controlled domain for security and compatibility reasons. So there is an overlay network domain, then the traffic is encapsulated at one border as in a marking node, and then decapsulated at the other border in an unmarking node, and all the transit node in the middle can read the data. There are two different flavors, two different type of measurement that can be done according to the usage of one flag or two flags. One flag allow packet loss and single marking measurement, while two flags allow packet loss as well, and delay measurement can be done in a more accurate way according to the double marking method. Next. Yeah, as I said, this draft want to be a reference for all the other relevant documents that can help the deployment of the methodology. In particular, here I mentioned some ongoing work that we also are moving in parallel with this document. So the YANG model that will be presented just after this presentation that propose the YANG model for the configuration. Also, the YANG push can be used for on-path telemetry, has been submitted and will be presented as a lightning talk. We also got adopted in OPSA-VG the IPFix information elements for the export of the alt mark measurement data. And we also have other documents in PSEP and BGP that are leveraging other control plane mechanisms to advertise and activate the altered mark capabilities. Next. Yeah, as a next step, so this is very straightforward document. So we want to make it stable, and the question for the working group is whether there is something else to clarify. And of course, in parallel, we want to move forward the companion documents on YANG data model. So comments are welcome. I see.
Xiaomin?
Yeah, Xiaomi from ZTE. As I recall, during adoption poll of this draft, I made a comment, suggest you add a reference to MPL's in-band PM encapsulation draft.
Yeah,
Yeah.
I added, yeah.
But I didn't see that reference in the updated version. So what's the reason? Why?
No, if maybe it's just I miss it. I will do in the next.
Oh, thank you. Thank you very much.
I thought I included, but maybe I missed. But I will do in the next. No, it was not intentional.
Okay, thank you.
Okay.
Thank you. So we will now move on to the section where we will be looking at documents that are not yet adopted by the working group, and we will also be looking at some related documents. But yeah, we'll keep Giuseppe on here.
Yeah, As I mentioned before, this is the draft, that is the Young data model for the alternate marking method. Yeah, I'm presenting on behalf of the co-authors. I know that there are so many, but I will reduce in the next version. This is just because it's a merge of two of two different drafts, and for now we keep all the names, but we will
Move to editor model.
next. Oh, sorry. Yeah, this draft, as I said, is the result of the merge of the two previous drafts on the Young model for alternate marking. Now we only have one data model. We agree on the structure and the related information. We try to be aligned as much as we can with the IOM data model in order to have some coherence in the IPPM working group. The Young model is shown below, so please have a look. And if you have some suggestion, we already had some feedback and some comments have been addressed. Next slide. Yeah, just to explain a little bit how what the alternate marking profile contains is the different information. So, for example, the profile name, that is the identifier for the alternate marking profile, similar to what we have in the IOM Young model. The filter that is used to identify flow. Of course, we are reusing Young filtering here. The method type that identified the type of methodology, single, double marking, protocol type. The node action that identify whether the operation on the flow is marking, reading, or unmarking. The period, that of course is important according to the deployment draft. The flowmon ID, that you may recall it's inherited by the RFC 9343. And of course, the measurement mode, whether it is op by op, end-to-end, and the enabling flags for loss or delay measurement, in case one want to enable only loss or only delay or both. Next. Yeah, we already received some comments and we were addressed in the new revision. The main changes are related to the alternate marking period made totally flexible. A new flag to indicate the type of method, single or double. We also solved the issue of Young model consistency, and IPv6 and the MPLS examples are provided. Maybe Xiao, you mean the MPLS example in this draft or in the previous draft? Because
No, I mean another draft that describes the MPLS encapsulation for alternate marking.
But for the Young model or for the deployment draft?
Deployment.
Okay, okay.
Yeah.
Okay. No, it's just to clarify. Okay. Next slide. Okay. As a next step, we asked to evaluate the working group adoption. We feel that we got some comments and that the Young model is in a good shape. So I think that the working group can start to work on it and consider the adoption.
Cool. Thank you. Any comments first from the group? Anyone here or online? Any broad support for, yeah, we should adopt? No? Anything? Any opinions? Yes? Okay, cool. I mean, so overall, thank you for, I mean, I'm always happy when I see, multiple proposals that can work together and come up with common docs. So thank you for doing that. I would ask that, I know you mentioned like the author list. Let's try to trim that down prior to adoption, since it's easier to do that then. That also has the side benefit of you will have more people who are supporting your work who are not authors. I mean, which is, I think, we do have a good contingent of people in the working group who are interested in this, who are working on it. But I think at this point, they're all the authors.
Yeah.
So I think we have sufficient number of people who are interested and will edit and help comment. But let's not have them all be authors. And I think it's easier for the working group to operate that way.
Yeah, yeah, it makes sense. Maybe we can figure out that in after the ITF meeting, and then maybe the working group adoption.
Exactly.
can be done later.
So I guess, for the purpose of the notes, Rakesh, just say, we'll have this on the slate to adopt after a revision.
A new version.
Exactly. Okay. Thank you.
Thank you. Okay.
So now we're going to go on to two drafts that are not targeted at IPPM, but they are relevant to this group. And the first one is a draft that has been adopted and is progressing, and I think it's near last call.
Yes.
In 6-man, and so we want to make sure that this group is aware and has reviewed this document before it progresses out of 6-man.
Yes. We also seek for your support in IPPM because this draft is strongly related to IPPM. Yeah. I'm Xiaomei from ZTE. This draft is on IPv6 query for enabled in-situ OEM capabilities. Next slide. This is a recap of this draft. This draft defines SMPv6 extension to achieve IOM capabilities discovery in IPv6 networks. As I said, this draft is a companion document of IPPM RFC, RFC 9359. This draft uses RFC 4620 as a basis. It reuses the ICMPv6 types assigned for that RFC. So there's no any new ICMPv6 types defined in this draft. For this query mechanism, 5 IOM capabilities objects are defined in this draft. Next slide, please. Here it's the message of IPv6 node IOM request. It's a ICMPv6 message. For node IOM request, this draft defines new queue type and new code and new data. The data is a list of IOM namespace IDs. As I said, there's no new types. So it reuses the already assigned types. Yeah, next slide. This slide shows the reply message. It's also a ICMPv6 message. So also no new types, but there's no new code and new data. The data is a list of IOM capabilities objects as listed in the first slide. There are 5 objects defined in this draft. And the queue type is copied from the request. So for reply, there's no new queue type. Next slide. This is an example of the IPv6 node IOM request and reply. Left diagram is the request, the right is the reply. In this example, there are 2 namespace ID, namespace ID1 and the namespace ID2 in the request. And in the reply, for each namespace ID, there were 2 IOM capabilities objects carried in the reply. First object is the IOM tracing capabilities object. The second object is the IOM proof of transit capabilities object. So this is the format, how to encode these fields into the ICMPv6 message. Next slide, please. Yeah. So next steps, the authors believe this draft is stable. And so we request a joint 6-man IPPM working group last call for this draft. And the last 2 slides in the slide deck are the recap of RFC 9359 and the history of this draft. So they are used to support our request. So that's it. Thank you.
All right, thank you for sharing the draft with us. Any comments, thoughts? I think mainly we just want to ensure that of our kind of IOAM experts, we can have some eyes on it. So I know we don't have like everyone who had worked on that in the room, but Justin, do you could speak?
Justin from ULH. Yeah, I just want some clarification about some security recommendations. What are the security recommendations from this draft?
Yes.
Could you elaborate a little bit? Because, I mean, you got to make sure that the source that wants your configuration is trustable, right? So what's in place in that draft? I got to be honest, I don't remember. I have read the draft a long time ago, so I don't remember the security considerations.
You mean you didn't see the security consideration in this draft?
Yeah.
I'm sure there is a security consideration section.
All right, let's talk about it right after. All right.
Yeah, please show the last slide. Yes, this is the history of this draft. So in a version 02 working group version, I think there's an improved security section. So from the received comments on the security part, so well, I'm sure there's a security consideration.
Please follow up on that offline, and if you have detailed comments, you can always address that in mailing list.
Okay, thank you.
Great, and we'll coordinate with 6-man chairs to, I think, just have the last call go out to both groups.
Sorry.
We'll coordinate with the 6-man chairs to make sure that when they send out the last call, it's also sent to IPPM, and that we get reviews there.
I think it's a joint.
Exactly right. Thank you. Okay. Tall, are you with us? Yes.
Yes. Can you hear me?
We can.
Okay, great. Okay, so this draft defines the ICMPv6 loopback, and it has been around for a while now, and we'd like to give an update about it. Next slide, please. So first of all, very briefly, what are we trying to do here? The idea is that the ICMPv6 loopback is kind of similar to ICMP echo, except that when we send the loopback request from the sender to the responder, that's what we see in blue at the top here. The reply includes the blue request as the payload of the reply. So that means we get back to the sender the original IPv6 header of the request, all the IPv6 extension headers, the options, and so on. And just as a side note, this is very similar to the way ICMP error messages work today. Next slide, please. So what do we get from this? First of all, the first use case is IOAM. So if we have an encapsulating node which sends a kind of a ping, a loopback request to the decapsulating node, we can get the reply, which includes the original IPv6 options of the request. That means also the IOM option. So that means using this IOM option, the sender, the encapsulating node can actually display the measurement-related information on the forward path. Next, please. And also there are a lot of other use cases which may benefit from loopback. For example, path tracing, which is a draft that has been presented in IPPM in the past. IFA, it can be used, for example, as the follow-up message in hybrid two-step. Okay, just the follow-up which comes after the trigger message. It can be used for SRH reflection. You get an SRH on the forward path, and then you get it back using the loopback reply. And there are a lot of different other use cases which are not described here. Next slide, please. We have been working on a demo. This demo is available, the code of this demo is available on GitHub. And the idea of this demo is it's very similar to Ping, to the well-known Ping utility, except that it uses IOM, so that we use an ICMPv6 loopback request, which has an IOM IPv6 option. And then when we get the loopback reply, we can display all the IOM related information to the user. And that's exactly what we see here. We basically get the same information as Ping, but in addition to that, we also have the per hop information of IOM. Next slide, please. So this is some of the discussions we had on the mailing list. I won't go over all the different comments. One thing that I think is important to discuss here is which working group this work should be discussed in. It has been presented in 6-man, and actually there was a different draft in 6-man which had a similar goal, but a different way to implement that goal. So since some of our main use cases are related to IPPM, it's not really clear whether this is a 6-man kind of draft or an IPPM kind of draft. So that's kind of an open question. Next, please. Okay, so what are the next steps? One thing is to potentially merge this. Like I said, there's another draft in 6-man, which is kind of similar in terms of the goals. So there are some discussions about the potential to merge these two drafts. In either case, the two drafts are mostly relevant to IOM as the main use case, but also to other use cases. And again, once we decide which working group is the best way to talk about this, working group adoption call is also something that we're happy to hear whether we're currently ready for that.
Excellent, thank you. So while Greg goes up to the mic, I think this is a good thing. We will coordinate with the 6-man chairs on this. And I think regardless of where we would make a potential adoption call, we will make sure to synchronize that across the groups.
Okay,
Greg,
sure.
please.
Yes, thank you. Greg Mirsky, Ericsson. Thank you, Tal, for presentation. I think that the very interesting topic might be to discuss and look at correlation of ICMP of the information collecting over the core path of ICMP packet compared to traffic that we assume that being monitored, for example, UDP. Because if I understand correctly, so because the ICMP is not a UDP based, so that load balancing in ECMP environment might work differently. So then their information the nodes links traversed by ICMP packet might be different. So diverted from the path of, for example, UDP-based packets. So that's
right.
something. That's something
Yeah,
that might be interesting to discuss and really say, so what measures could be taken to make this correlation accurate, and then um, for example, on-path telemetry and operational state information relevant to the path that's being characterized. Okay, thank you.
yeah, right. I think the question of ICMP versus UDP, or actually ICMP versus STAMP, is a valid question. I think, there are two valid protocols the IETF is working on. Each of them has its own use cases. I don't think it's either one or the other. I think it's actually both, but potentially in different use cases. Like you said, when you use STAMP over UDP, it allows you to mimic the behavior of ECMP, so you may be able to forward packets through different paths. But ICMP is very widely deployed in a lot of different environments. It's deployed by switches, routers, as well as hosts. So again, I think there is a valid use case for both of them. I think I think it's good that we're working on STEM in this context, and I think we should also be working on ICMP in this context.
Yes. Okay, let's continue on the mailing list. Thank you.
Thanks.
Rakesh?
Rakesh Gandhi from Cisco Systems. I agree with you, Tal, that yeah, there is case for ICMP for many parts of the network, or many operators would use that, and there is case for STAMP. So both are needed. Thanks.
Thanks.
Okay. Any other opinions in the room about kind of like the venue for this work progressing? That's one thing we'd like to hear people chime in on. We can also do that on the list, certainly. Okay. Very good. All right. With that, we are moving on to our lightning talk section. Thanks, all. So we don't have a lot of time. We have 13 minutes. We have too many drafts to get through. But again, our general approach here is that we want just kind of like a one slide intro to the various topics. So let's start with, the ones from Hangxi. If we can kind of pick just tell us like one slide to jump to that we want to cover, and just have a very quick introduction to the group on your topic.
Yeah, I can go to slide 2. Actually, I can go through the slide very quickly. Yeah. So I would like to discuss a new mechanism called congestion measurement for collecting the congestion metric of the path, including the bottleneck bandwidth or queue utilization or total queuing delay, for use cases such as node balancing or congestion control and network debugging. Basically, the sending node mark the congestion measurement header, and the transit node will update the congestion info in each hop, and the receiving node will export the congestion measurement result. Next slide, please. Yeah, here is a very simple example. For example, we would like to measure the bottleneck bandwidth utilization, and it will be updated per hop. And the operation in per hop is a max, so it will only update when the bandwidth utilization is bigger than the value in the packet. And here we define a lot of congestion info, and it's packed in a bitmap multiple types, so you can collect in multiple congestion info at the same header. And the main point is that it's a fixed header size, because each hop only updates the congestion info value. It will not add any new information. And this header can be encapsulated in various data plane. We propose the IPv6 DOH or hop-by-hop header encap in the following draft. We welcome the discussion or comments. We are open to the suggestion of the congestion info or encapsulation. Yeah, that's all.
Okay. Thank you very much. And if anyone has comments, please engage with the authors and on the mailing list.
Okay, hello, can you hear me?
Let's get one second.
Can you hear me? Come on.
We hear you. Yes.
Here we go.
Okay. Hello everyone. This is Jimmy from China Mobile on behalf of my co-authors. I'm going to introduce flow measurements in IPv6 network, including 3 drafts. Next, please.
All right, and yeah, for these, can we let's figure out which slide would you like to focus on for the lightning talk here?
Okay, the first one, maybe.
Okay.
In the first draft, we defined a flow monitor option to mark the mark the measured IPv6 traffic by encapsulating it in a different position of IPv6 header. The measurement mode of end-to-end and hop-by-hop can be achieved. So next, please. And at present, both China Mobile and China Telecom have organized IPv6 flow measurement tests, and some manufacturers have supported and passed the relevance test. Moreover, China Mobile Zhejiang branch has also carried out practical deployment. So next. The second draft is an extension of flow monitoring option due to the current multi-level network controllers, resulting in insufficient measurement accuracy in IPv6 traffic. In order to obtain better SLA, we defined a distributed measurement method in this draft. So next, please. The measurement mode are divided into types, source node mode and end node mode, which respectively represent the nodes responsible for completing the computing tasks, whether the source mode or the end node is responsible for the computing. The information transfer on the measured path is increased. Therefore, some TLVs are defined in this draft to complete this work. And next, the third draft, please. The third draft was complete to solve the inconsistent round-trip path problem of TWAP in SRv6 policy measurement. By encapsulating the path segment in the SRH, the reflector can complete the mapping of the consistent round-trip path. Okay, next, please. These 3 drafts have been presented twice in the IETF 115 and 118 IPPM working group meetings. Therefore, so this time we want to ask for adoption guide and some comments and feedbacks.
So thank you, and thank you for actually being very fast going through this, even though it's several slides and several documents. Please, to everyone who thinks this is interesting, engage on the list and discuss this. This allows us to give the documents more time on the next meeting, and then we can move further and consider things like adoption calls and so on. So please, everyone, if you're interested in this, engage.
Please post your comments on the mailing list. Thanks. Thank you.
Thank you. All right. You have one slide, right?
Yeah. This draft is related to the deployment draft, alternate market deployment draft, but it's about the young push, so the on-path telemetry. We called on-path telemetry because included both alternate marking and IOM telemetry data. So you see that the young model is a little bit longer, but we included both. And we try to, of course, use some parameters that are in common, like timestamp, acquisition method, emission type, and so on. This is the first draft, so please have a look and comment.
Oh, is there another deck?
Oh yeah, it's your fault.
Yes. Like lightning.
There we go. Sorry. Next. Yeah. Yeah, and this draft is related to the comment with the discussion with Rakesh. So, as I said, in several scenarios, active measurement, bottom biop, and end-to-end are needed. So, with active test packets can be used in combination with hybrid methods to perform on-path active measurement. So, the case of ECMP, ICMP V6, OWAMP, TWAMP, STEMP, where the hot biop option, for example, in case of IPv6 header, can be used in combination with active tools to perform on-path active measurements. So this is just to generalize the idea. Different alternatives are possible. You can use YANG to configure IPFix or YANG notification to report telemetry data, and of course the stamp TLV as proposed by Rakesh in case of stamp, of course, since the draft is general. So also in this case, I'm open to cooperation. So if you are interested, we can cooperate, and please have a look and comment.
Thank you.
Hello, can you hear me?
Yes, we can.
Okay. This is Li Zhao from Huawei. Let's go to the third slide.
Third slide, you said?
Yes, we can jump. Oh, okay. So the problem is that in some scenarios, the data center can't know the return path in advance, but it requires the return path be the same as the forwarded path to do a round-trip performance measurement. So we define a new flag in the stamp return path control code sub-TLV to indicate the transit node to insert the node information to the and the session reflector to replace the reflected text packet along the same path. And the figure below shows an example of the routed bidirectional path measurement. And please go to next slide. And next. And next. Okay, and this draft is a stamp intention for multipass. Also, we have the multipass measurement could be achieved by constructing different IPv6 flow labels or MPLS entropy labels, but it's hard to know whether all the available paths has been measured. So we extend the stamp with a multipath TLV. The TLV contains a bit to indicate whether this text packet is for a multipath measurement or not. If there are multi-paths to the destination, and that node needed to replicate the test packet at each outgoing interface. This multipath TLV need to be combined with the reflecting stamp packet headers extension to indicate the route path collected in the IOM trace option. And furthermore, if you want to perform a round-trip measurement, it still needed to combine with the correlated bidirectional path measurement intentions. And the figure below also shows an example of multipath active round-trip measurement. And that's all. Thank you. Any comments and suggestions are welcome. Okay.
Thank you very much. And we actually managed to
Yeah.
run through all the lightning talks on time. That's pretty amazing. So thanks to everyone for brief and lightning fast presentations. And to all of you who have seen these presentations, please, if you think this is interesting, any of these topics, reach out, discuss them. This makes it much easier for us to understand which documents are relevant to schedule for more time on the agenda and also figure out what could be candidates for adoption in the working group.
Okay, with that, thank you all for participating, and thanks to our note taker. Appreciate your being coerced into doing so. All right. Have a great rest of your week, everyone. See you around. And on the list.
Oh, no worries, no worries.
We have a way forward, so. That's good.
Yes, yes.
So yeah, yeah. Wait, do you mean like to a last call again? No, just. Oh.